what skills do you need to work with LLMs? And work with LLMs could mean whatever you interpret it to mean. But I'd really be interested in your thoughts on that as an LLM educator and researcher.
Yeah, so I would say, yeah, it's almost like, I mean, you can think of an LLM as a PyTorch model, really. If you are familiar with deep learning, I don't think there is much new in there where so if you have done deep learning before, you will recognize basically everything. The whole training loop, you use the same cross entropy loss, you use the same learning rate scheduler, gradient descent, backpropagation, like all these concepts from deep learning, they're the same when you train LLMs in that case. So I think if you have a background in, like deep learning, it's pretty easy to get started with LLM training. It's kind of like the same concepts, hyperparameter fine-tuning, looking at loss curves and stuff. The only challenge is that LLMs can be bigger. So in that case, it is so you have to think a bit more. I mean, at least for me, it was like that. Before I trained things on a single GPU, for example, when I trained convolutional neural networks, maybe on multiple GPUs sometimes, but it was kind of cheaper to do that. Like you could fit everything into one GPU if you wanted to. You used maybe distributed data parallelism to make it train faster, but technically, usually most of the time, you could fit the whole model into a single GPU. And with LLMs, depending on what size you use, this could be a bit more challenging, which is where you maybe have to pick up some new concepts. So it's like it's still a deep learning. Fundamentally, it's deep learning under the hood. But in addition to that, I think it's computationally adding a few more, not restrictions, but challenges. So, for example, multi-GPU training is almost a requirement I mean, it's not required, but I think, it helps if you are familiar with multi-GPU training. But also, like mixed precision training, lower precision formats like bfloat 16, which is like a special 16-bit precision format, to lower the memory requirements instead of training models in 32 bits and these types of things. But also maybe saving checkpoints and continuing the pre-training later when, because usually, I mean, things might crash or you don't have time to finish the training. You want to make checkpoints to maybe if something goes wrong to rewind and stuff like that. So it adds more like these engineering challenges. So for me, it was something where, yeah, I had to pick up a few new skills. Also, when I joined Lightning AI, coincidentally, we are developing PyTorch Lightning and a library called Fabric, which makes that relatively easy on top of PyTorch. So in PyTorch, I mean, all these things exist, multi-GPU training with fully sharded data parallelism, tensor parallelism since the last PyTorch release too, and also checkpoint, as we can save checkpoints, load them and stuff, but it's very, I would say, verbose. So it's like if you use, let's say, Seaborn for plotting. I'm not sure if you're familiar. It's like
Big fan
it's
of
a wrapper
Seaborn.
around, yeah. So so it's like a wrapper around Matplotlib. You can do all the things that Seaborn does in Matplotlib, but it would be a lot of code. So in that case, Seaborn makes your life easier that you can focus more on the concepts and what type of plot you create, rather than, let's say, the nitty-gritty managing of all the colors and all the layouts and stuff.
Mm.
And in the same way, a PyTorch Lightning and Fabric help you manage your PyTorch code that you don't have to micromanage all the, different GPUs, what they're doing and how to distribute things and stuff like that. So it's really, you can do that once you have the code in the format that PyTorch Lightning expects or Fabric. You can change one line of code and change it from single to multi-GPU training. You don't have to change anything else or mixed precision training. So in that sense, there are tools that exist to make it easier, but yeah, still there are things to think about when getting into LLMs. So yeah, so I would say mostly from a deep learning perspective, everything should be familiar, but yeah, you have these additional, I would say, challenges for scaling up the computing for these
Yeah.
larger models, essentially.